All right, boys and girls, here we go. Been a minute since we've done one of these. Hope you guys are keeping up with things. Don't get too far behind. It's our last week of new material. So make sure you're keeping up with the new stuff we got this week. I got a test at the end of this week, and then we'll start getting ready for the big test, the big semester test. So here we go. Solve quadratic equations. So we've talked about solving equations a ton, right? So if you have a equation with addition in it, you solve by doing the inverse operation. You subtract. If you have one with multiplication, you do the opposite of multiplication, which is division. All right, so now, got a little curveball for you. What operation is this? What does this say? What does this mean? Good, it means x squared. So, the opposite of addition is subtraction. The opposite of multiplication is division. What's the opposite of squaring something? Hint, hint, we spent all of the second triad talking about it and doing it. That's right, boys and girls. The opposite of squaring is square root. So the way you're going to, don't moan and groan, I don't want to hear it, quit whining, okay? The opposite of squaring is square rooting. So what you're going to do to solve this equation is square root both sides. That's how this works. So I said these are opposites. Well, just like, pause for a second, okay? If I have x plus 3 equals 5, and I go minus 3 on both sides, the opposites, they make 0, right? But more importantly, it just leaves me plain x, gets x by itself. So, same idea, same concept here. Square root and square, those are opposites of each other. They undo each other, they make each other go away. So now I have just plain x on the left-hand side of the equation. Square root of 36. We did this a lot. So when I have square root, I go to my factor tree and break it down. So I'm gonna go sideways with my factor tree this way. So what goes into 36? 6 and 6. What goes into 6? 2 times 3, 2 times 3. So I've got 2 2s and 2 3s. That's right, boys and girls. This isn't going away. It's coming back with a vengeance, okay? I got a pair of 2s getting out. I got a pair of 3s getting out. When they get out, they get multiplied. 2 times 3 is 6. Is there anything left inside the radical? No, nothing left inside the radical in this case. So 2 times 3 is 6 on the outside. Nothing left on the inside. Now, a couple of things I want to run by you before we do some more of these examples. This isn't the whole answer. I got to show you something else here. Put this whole problem on pause for a second. What is 3 times 3? Sure, 9. What is negative 3 times negative 3? Negative times negative is positive 9. So, if I'm working backwards and I say what two numbers that are exactly the same and multiply together to be 9, I don't know if it's positive 3 times positive 3 or negative 3 times negative 3. Both of them work here. They both equal positive 9. Two different ways I can get that answer. Because there's two ways I can multiply to positive 9. The positives do it and the negatives do it. On all of our answers today, all of our answers, whenever you see this, all of your answers need to have a plus minus in front of them. Because it's positive 6 times positive 6 is 36, and negative 6 times negative 6 is 36. So there's a positive negative in front of all of our answers. All of them. All right. So, one last thing to remind you of. We didn't talk about this a lot in that last chapter, kind of hinted towards it. But there are some numbers that when we do the square root, there's nothing left on the inside. Those are called perfect squares. If you know and recognize a perfect square, like I know 6 times 6 is 36, it's automatically going to be a whole number 6. Some of you can recognize those when they come up. Some of you can't, okay? It just doesn't register. That's fine, okay? You always have your factor trees and your radicals to break down. So, number 2. I have x squared. What's the opposite of squaring? Square root on both sides of the equation, okay? Opposites, square root and square roots. Opposite gives me just plain x on this side. Square root of 40. Is 40 a perfect square? Do I have two numbers that are the same number that multiply to be 40? 4 times 10, that's not the same number. 2 times 20, that's not the same number. 8 times 5, no, it's not a perfect square. If it's not a perfect square, you have to do the factor tree. 40. 4 times 10. 4, 2 times 2, 2 times 5. Notice I'm going sideways with my factor trees because I'm just trying to save space. There's no particular reason for doing it. So I've got 2, 2, 2, 5 in my radical. Pairs of numbers get out of the radical. Pair of 2's out. Is there another pair left? Nope. So I got the 2 on the outside. If there's more than one number left inside, what are we going to do? Multiply, absolutely. And what did I tell you goes on all of these answers? All of them. Plus, minus. There you go. There's the answer. Number 3. Did I forget to put a 3 up there? Make sure you're writing these in your notes. X squared. What's the opposite of squaring? Square root. Both sides. Square root and square. Opposites. They're gone. Just plain X. Is 100 a perfect square? Some of you got it. What's the same thing multiplied by itself that equals 100? 10 times 10. If you can think of a perfect square, that's the answer. The square root of 100 is 10. But, what did I forget? Plus minus. They all get plus minus. Remember, so they don't have to have a radical in the answer. Sometimes they do, sometimes they don't. If it's a perfect square, no radical in the answer. Perfect square, no radical in the answer. All right, that's it. If you can remember those perfect squares. If you don't remember perfect squares, break it down with a factor tree. All right. Number 4. X squared equals 60. What's my first step? Square root, absolutely. So square root and squared are opposites. Plain X is 60 a perfect square? Nope. I can't think of anything that multiplies to be 60. That's the same number, so I got to go to the factor tree. I'm going 6 and 10. 2 times 3, 2 times 5. So I've got 2, 3, I got 2 2's. A 3 and a 5. 2's out. 3 times 5 is 15 on the inside. And what do I put in front of all of my answers when I have an x squared? Plus minus. I only have to do that on x squared problems. If not an x squared problem, I don't have to do that. All right. That's it for today. We'll get harder as the week goes on. Not too much harder, but harder. Good luck. Ask questions.